Hello, everyone. Welcome to our Summer 2024 TeamsCode contest. We're having a bit of technical difficulties right now, so we'll start in a minute, but
All right. Hopefully our issue should be resolved now. Sorry about that. Hi, everyone. Welcome to the Summer 2024 Teams Code Programming Contest, our 10th online coding competition. My name is Brian.
my name is Eric.
I'm thrilled to be here with all of you today and greatly appreciate all the support. Before I begin, I'd like to give some background on the contest for new participants. Okay, there we go. Sorry about that. TeamsCode is a student-run nonprofit organization that hosts coding contests to promote student interest and activity in computer science. Since 2017 in Seattle, Washington, we have expanded to serve CS students all around the world. Through our contests, we hope to provide students with an insight into competitive programming while creating a collaborative environment to practice and showcase their coding skills. We hope that helped you to learn about TeamsCode. Let's get to today's schedule. From 11:15 to 11:45 is the contest opening ceremony. We'll go over the rules and introduce our sponsors. Coding begins at 11:45 and will end at 2:45. You'll have 3 hours to solve around 10 problems with your team. Then, please take a 15-minute break and join us at 3 p.m. for speaker events featuring Roman Bohuk and Zhen Qian. Starting at 5, we'll announce contest winners and also hold the raffle. Now, let us introduce the partners and sponsors that made this contest possible.
TeamsCode's first partner is XCamp. XCamp is founded by Google engineers and a former NOIP champion, aspiring middle schooler and high schoolers with a rigorous computer science curriculum, from beginner to international Olympiad in informatics IOI level. Beyond textbooks, a crafted learning journey, XCamp surpasses traditional education. Their meticulously crafted curriculum uses unique teaching methods, proprietary problem sets, and a dedicated platform, fostering a deep understanding of CS fundamentals. Learn from the best. XCamp's top-tier faculty features senior engineers from high-tech companies and distinguished computer science students from MIT, Stanford, and UC Berkeley. For competitive programming mastery, their USICO Grandmaster class boasts medalists from IOI, NOI, and ICPC, ensuring unparalleled guidance. Proven success, a legacy of excellence. Over the past 7 years, they propelled over 300 students to USICO Silver and above, with 12 USICO finalists and over 40 Platinum Division qualifiers. Their 2023-2024 season saw continued success, with 18 new Platinum qualifiers and a remarkable 90% pass rate. XCamp attracts students worldwide from the US, Canada, China, Singapore, Hong Kong, and Europe. Visit XCamp at x-camp.academy to begin your coding mastery journey today. Now let's hear from XCamp's co-founder, Mr. Charlie Guo.
Thank you, Eric. This is Charlie. I'm the co-founder and the principal of XCamp. Today, I like to just quick share about served community. Here's a quick introduction about XCamp. Let me play the video.
Computer science and artificial intelligence are tools that will change the future. XCamp Academy is a community dedicated to inspiring and cultivating the next generation of computer science and artificial intelligence talent. XCamp Academy was founded in August 2017 in Silicon Valley by two Google software engineers. The name XCamp was inspired by the variable X, which represents unlimited opportunities. XCamp's curriculum system and training methodology is inherited from Mr. Xian Youxu, a Chinese diamond-level international gold medal coach. Our staff here in the US is mostly composed of senior software engineers from tech companies in Silicon Valley and prestigious CS students from top universities. In addition, we have strong support from international and domestic competition winners in our coach team. From beginner-level Python to classic C++ courses and competition honors courses, XCamp's curriculum is designed for students of all different levels. By participating in team-based competitions and facilitating frequent group study sessions, XCamp also fosters an environment of collaboration to build each student's confidence in their ability to code. As of mid-2024, more than 300 XCamp students have reached the USICO Silver Division and above, including 60 in the Platinum Division, and 27 were selected in the US and Canada national camps, out of which 15 were fresh in the 2024 season and 2 were selected for the US national team. In renowned high school contests, Stanford's Procol and UC Berkeley's Calico, and other prestigious US programming competitions, such as the Harvard Programming Invitational, TeamsCode, and Lexington Informatics Tournament, XCamp students perform well, and we encourage students from being participants to problem writers and organizers. In 2024, our students received 13 MIT offers and many more from Stanford and UC Berkeley, thrilling us all. Here at XCamp, we believe that children have unlimited potential and can change the world through coding.
Thank you. Today, I want to talk about a student's journey with XCamp. His name is Jay. He started coding with XCamp from 6th grade. At 10th grade, he was accepted to USICO US National Camp. Then he created an NGO to teach kids math, coding, science. Also, he was one of the leaders of TeamsCode. He accepted to several good schools. From his experience, Alex say also I want to share with you, learning coding is great. You build skills, you learn knowledge. This also may help you build a future career. Also like to say, serving community is another journey. The leadership is one of the skills or capability or characteristics you need to build. Because besides the work you will do, serving community might be one best way to help you to enjoy your life. Because here are like 3 questions I believe some of you or all of you will answer in your life. The first one is, what do I enjoy to do? The second way is what I'm good at. So sometimes you enjoy to something, you might not be good at that. What you are good at is kind of your gift, your talent. It's good for you to find them as early as possible. And finally, you might ask yourself, what's my value to the community? What will be my contribution to the community? Yes, I want to share this with you because I believe these questions are very important to you. Learning coding is just a start of your life, but to answer these questions, to find who you are, to find what you can contribute to the community is even more important in your life. Yes, if you like to learn coding, XCamp provides now show the 3 set of classes. The first one is online weekend classes. We have all level from introduction to we call the CS 603. It's kind of international Olympiad of Informatics medalist level. The next we have 10 online mock tests before this USICO season. It's from October to December. Every weekend we have a mock test for the bronze level to platinum level. Also, we will have 1 week winter camp. It's from December 26th to December 30th. Now we are in a summer camp. A lot of our students enjoy this kind of in-person camp very much. In addition, we have 100 coupon code for all these TeamsCode contestants. It's called TC100. Later, when you register to XCamp class, please, you can use this code. You can get $100 discount. Yeah, thank you all. Wish all of you have a good contest today. Thank you.
Awesome. Thanks so much, XCamp. As an added incentive, any participant who signs up for XCamp with this coupon code will also receive a $10 Amazon gift card. Now, I'd like to introduce our next sponsor, vPlanet Coding. Our next sponsor is vPlanet Coding. vPlanet Coding helps USICO competitors advance to the next division in a matter of weeks. vPlanet has talked to over 100 USICO finalists and determined how they fast-track their USICO progress, and they use that to help you fast-track your own progress. Our next sponsor is Luminar Central. Luminar Central is a group of driven college students from schools like MIT, Harvard, Stanford, and UC Berkeley who want to help you succeed. Whether it's one-on-one advice, essay editing, or tutoring, we want to impart the best of our knowledge to you. We've been there and done it. Do you want a mentor who made USICO or USIFO camp? A Regeneron International Scientist and Engineering Fair winner? A nationally ranked top 8 debater? An internationally acclaimed cello soloist studying physics and mechanical engineering at MIT? A Harvard, Yale, Princeton, Stanford, and MIT admit who also received $600,000 in scholarships? Then come to Luminar Central and book a one-on-one session today, where you'll receive personalized advice from the top college students in the country. We would also like to thank Interview Cake, Recursive Dragon, and Art of Problem Solving for their support. Interview Cake is a study tool that preps software engineering candidates for programming interviews. Interview Cake is focused on being the fastest, easiest way to become the kind of candidate companies fight over. From its inception, the mission of Recursive Dragon has been to promote algorithmic thinking and instill a love for programming in young minds. Students are matched with a mentor from a small team of CS majors, potentially progressing from introductory level programming in Scratch, Python, or Java, all the way up to the highest level of USA Computing Olympiad. And Art of Problem Solving develops educational resources for eager math students in grades 2 to 12, including textbooks, an online school, in-person learning centers, and a variety of online applications. They build the tools they wish they had when they were students. Thanks so much to our sponsors. Our contest would not be possible without them.
Now, onto our prizes. Each member of the top 5 teams in both divisions will receive Amazon gift cards in different quantities depending on placement. In the advanced division, first place $100, second place $50, third place $40, fourth place $30, fifth place $20. Each member of the top 5 teams in the novice division will receive the following prizes. First place $30, second place $20, third place $10, fourth place $10, fifth place $10. The top 5 in each division will also receive an Interview Cake full access license. We will also be having raffle prizes, and you are eligible for raffle prizes if you make at least one submission today. We will be offering 2nd Gen Apple AirPods, 5 Discord Nitro subscriptions, a Red Dragon gaming keyboard and mouse, and 4 $25 coupons for Art of Problem Solving.
Before we kick off the contest, we'd like you all to join our Discord server if you haven't already. This will be used for important announcements and communication with the TeamsCode staff throughout the contest. You can find the invite link in the description below. During the contest, ask questions using our ticket bot in our Discord server. I'll give you some time now to go to the link and join our server now. We are excited to announce that we will have Roman Bohuk as this guest speaker today. Roman Bohuk is the co-founder and CEO of MetaCTF, a cyber skills platform that helps companies assess, recruit, and upskill cybersecurity talent. Since 2014, his team has run over 300 cybersecurity competitions for various companies, universities, and conferences, including the 2023 International Cybersecurity Challenge and the 2023 Mid-Atlantic Collegiate Cyber Defense Competition. The title of his talk is Cybersecurity Careers and Competitions. We are also excited to announce that we will have Zhun Qian, the Vice President of Engineering at Oracle, as a guest speaker today. Zhun Qian is a seasoned executive with over 25 years of experience in pioneering technological innovation in AI and machine learning, with a track record of steering world-class engineering teams at global tech giants like Oracle, Microsoft, and Amazon. He has proven expertise in executing ambitious AI initiatives, driving strategic partnerships, and propelling organizational growth through cutting-edge research and development. The title of his talk is Artificial Intelligence. Now for our contest rules. The novice and advanced division have around 10 problems each. All problems are worth each 100 points. We will be providing partial credit for every problem. Each problem has some number of tests, usually 10 or 20. If you solve X test correctly for a problem with Y test, you will get X divided by 10 times 100 points. Moreover, some problems will have explicitly stated subtasks. For example, a problem with 10 tests may have cases that are tests 1 through 5 with n less than or equal to 10, and tests 6 through 10 with n less than or equal to 100. Note that some problems may also have individual test cases inside each test that you must get all correct to get points for that test. The sample test given in each problem does not give you any points. You will only be competing against other teams in your division. The difficulty of each problem increases progressively as well. Each problem will have unlimited attempts, and the last time of submission that increased total points is the tiebreaker.
To submit your solutions, navigate to the Submit Code section at the bottom of the corresponding problem on the contest page. Copy-paste the code you have written or submit the source file. Each problem has a time limit that your program must run in less time than. C++ time limit is usually 1 or 2 seconds. Java time limit is 2 times the C++ time limit, and Python time limit is 4 times the C++ time limit. For most problems, your solutions also must use less than 256 megabytes of memory as well. Note that specific problems might have different time and memory limits. Please note, if you're using Java, you must name your class main with the M capitalized for every single problem, or else the code will not compile. Also, if your code runs slowly, try using buffered reader and buffered writer for your input and output. Lastly, click the rank list button at the top right of the page to refer to our scoreboard to see your team's total score. We will be displaying the top teams from each division on stream during the contest. The rank list will freeze 45 minutes prior to the end of the contest. Here's a set of steps on how to log onto the contest website and get coding. I'll give you some time to read through it. And with that, you're ready to compete. From now until 11:45 a.m. Pacific time, we will be answering any questions you might have about the contest. You may ask your questions in the live stream right now, but during the contest, if you have any questions, we prefer you to create a ticket in our Discord server. Specifically, we have a channel called Tickets, and this will be the only channel unlocked during the contest. If you cannot do that, feel free to email us at contact@teamscode.org. If a question is important enough, we will announce the clarification on the live stream and in Discord announcements. See you guys at 11:45.
All right, so from now until the contest starts, we'll basically just be answering any questions in the chat. Okay, guys, it's 11:45 a.m. Coding begins now. You should be able to see your problem set on the right side of the contest page once you log in. Please have at least one team member stay on the live stream or Discord for announcements. We'll also have a live scoreboard and the official timer on stream. Good luck, everyone. See you at 2:45.
Hey guys, there's only 1 hour remaining in the contest. Hi everyone, it's 2 p.m. The leaderboard will now be frozen. There's 45 minutes remaining in the contest. Good luck. Hi everyone, there's only 5 minutes remaining. Finish up your last problem and make sure to get them submitted before 2:45. Remember that one submission will make your entire team eligible for the raffle. Hey everyone, the contest is officially over. Please take a 15-minute break and we will resume with speaker events at 3 p.m. this afternoon. After the speaker event, we will announce contest winners and raffle winners at 5 p.m. See you at 3 p.m. Hi, everyone. Welcome back to our speaker events. My name is Brian, and again, thank you for all of your support today. I'm super excited to announce that we have two esteemed speakers here with us today. Roman Bohook is the co-founder and CEO of Meta CTF, a cyber skills platform that helps companies assess, recruit, and upskill cyber talent. Since 2014, his team has run over 300 cybersecurity competitions for various companies, universities, and conferences, including the 2023 International Cybersecurity Challenge and the 2023 Mid-Atlantic Collegiate Cyber Defense Competition. He will be speaking about cybersecurity careers and competitions. Now, I'll hand it over to Mr. Bohook. Please ask any questions you have in the YouTube livestream. Thank you. We're unable to hear you.
Can you hear me now? Can you hear me okay?
Yeah, that's better.
Okay, nice. Sounds good. All right, well, thanks, Brian. Thanks, everyone. It looks like the competition has ended, so congrats to everyone, for participating. My talk today is going to cover cybersecurity careers competitions. Throughout, since high school, I've been participating in a lot of different events and a lot of different competitions. I love cybersecurity as a career field, and I want to share kind of some insights, some things that I learned. A lot of you might not be familiar with what cybersecurity might entail or what cybersecurity jobs are available, and so I want to demonstrate that it's a great field to be in. So here's a little bit of my life story. I went to Deep Run High School, graduated in 2017, and since I was very little, I was always very interested in math. I was fortunate to be in a special IT program at my high school, and that's where my passion for mathematics kind of gradually converted into an interest in programming, computer science. Also in high school, I got to meet a lot of great mentors, a lot of whom had cybersecurity jobs. Talk to us about what that was like. I participated in a lot of cybersecurity competitions, and I also couldn't really find kind of a specific field in computer science that was really interested in. I was interested in system administration, I was interested in programming, I was interested in, in hacking and in network security, all kinds of things. And cybersecurity for me was this kind of field that kind of combined all of these different other fields in it. It seemed like the most general field, and that's why I really liked it. So for those of you who are in high school, so I used to do Cyber Patriot all 4 years of high school, and I also participated in a lot of programming competitions. So UVA, BT, BCU programming contest. When I went to UVA, I actually ran the UVA contest a few times, UVA programming contest. And I guess when I went to college, I was already mostly set on being in cybersecurity. Unfortunately, UVA at the time, it's still not really. UVA didn't really have a great cybersecurity program. They have some really good classes, but there was no cybersecurity major. And most of the things that I learned came from extracurricular activities. And so I participated in a lot of different cybersecurity competitions, including CCDC, a lot of CTFs. Our team traveled a lot. I helped revive UVA's cybersecurity club. And I also interned at a handful of companies, both in security and non-security roles. And so I have some experience there. And then when I graduated in 2020, I started working full time on my startup. So MetaCTF started as a project back when I was in high school. In addition to participating in a lot of competitions, we really liked running them. And so we organized a few competitions here and there and then started running them at conferences. Companies started reaching out to us. At UVA, we were exposed to a lot of entrepreneurship, events that were really part of the entrepreneurship community there. And because of that, we decided to kind of take MetaCTF as a project, incorporate and see where it goes. And then after I graduated, I was able to take it full time. And since then, running competitions has been my full-time job. So we've done some really cool events internationally, a lot of different conferences, including the International Cybersecurity Challenge, which is I guess you can say kind of the Olympics of cybersecurity competitions. CCDC, the competition I used to participate in when I was in college, I helped run when I was, after I graduated. But so, a lot of these experiences kind of shape what I'm going to talk about today. But if you have any questions, post them in the chat, and I'll be happy to answer them. So yeah, here was it. Why is it not? All right, yeah, here's some proof that I have done those things. So cybersecurity. I'm sure all of you have heard of the term, and many of you are probably interested in cybersecurity as a field. But it's a really general field. There are thousands of different job roles within cybersecurity, and there, you can find 10 different definitions. But I think you can narrow down to, I guess, the practice of just protecting systems and data. Often you'll hear people reference something called the CIA triad, which I think stands for confidentiality, and integrity, and availability. So kind of ensuring that the data is, protected, confidential, it doesn't get changed, and that it's always available. So, it is. I used to do a similar talk, for many years, like since 2017, and I used to have to kind of explain why cybersecurity was such a big deal, but now you hear of these crazy things happening almost every day. Oh, like this pipeline blew up, this CrowdStrike to well, I guess CrowdStrike is some might characterize it as a cybersecurity incident, some might not, but systems went down worldwide. Car dealerships got hacked. So nowadays you hear about these things all the time, and so it's I don't really need to explain why it's important. But just to put some numbers to it, there's a huge cost associated with cybersecurity attacks. So an estimate that in 2025 it's going to be 10.29 trillion. There's a huge number of unfilled cybersecurity positions, and it's still growing. This metric, 3.5 million. You'll hear different numbers based on where you look. It might be anywhere from 3 to 5 million. I will say that this metric can be a little bit misleading. Some people might take it to think that it's very easy to get a job in cybersecurity. But unfortunately, a lot of companies still have this idea that they can only hire people with a lot of experience. And so that's why it's more like 3.5 unfilled experienced positions. But there are some ways to kind of get that experience if you're interested in the field. Yeah, and some other numbers. But why you should learn about it is that a lot of companies have started adopting, I guess, a methodology. It's called Secure by Design. It's been around for a long time, but CISA, it's a government agency's Central Information. I have no clue. I'm not going to try to come up with abbreviation, but recently, kind of I guess they recoined the term and started encouraging companies and organizations to follow it. But what that means is that you can't just rely on security tools to make sure that your network, your company is secure. You have to build systems. You have to design systems in such a way that security is taken into account, during the design and implementation process. So, for example, there are things called like web application firewalls. What they do is they sit between the internet, and your web application, and they monitor web requests. And if some of them are malicious, if it tries to identify malicious requests, deny them, log them, and so forth. And the idea behind this is that you can't rely on these tools like web application firewalls, regular firewalls, to do all this for you, because things will inevitably kind of slip through. And so even if you're just going to be a developer, even if you are not even going to be in a technical role at all, as a developer, you need to write code that is secure from the get-go. And if you're not in a non-technical role, you will also be exposed to a lot of I guess threats. Often you'll hear kind of cybersecurity being talked about in the context of like these really technical topics. But I think the reality is that most of the, well, I don't have the exact number, but I think most of the attacks start from social engineering. So even if you're a non-technical role, a lot of the you're most likely going to be exposed to something. And like I mentioned earlier, it is a growing job market. So a cybersecurity career can be pretty lucrative. And so yeah, you should definitely consider it. There are a lot of different ways of grouping the different cybersecurity careers. This is just my attempt at grouping them. There is a framework called NIST NICE published by by NIST. I think it's a great attempt. I don't necessarily agree with kind of all of the groupings because for example, some more offensive roles like penetration testing are very hard to fit within this framework. But here you can see some of the different roles that might be associated with cybersecurity. Most of them are technical, but a lot of them are less technical. So I'm going to quickly go through a few of them. And once again, if you have any questions, feel free to ask. So probably the most kind of, I guess, well-known and the most envied job role is like penetration tester, red teamer. I guess you can also kind of group bug bounty hunter into the same category. What this means is you proactively kind of perform attacks on different systems, networks, websites. You try to analyze them, find flaws, discover vulnerabilities, and then you write a report, and then you advise the customer on kind of what you found and how some of these vulnerabilities might be fixed. So the difference between a penetration tester, red teamer, and a bug bounty hunter is that penetration tests are usually done by a third party. So for example, if I have a company and I want to assess the security of my network, I might hire some kind of third party to run a penetration test against my business to test kind of how they can break in, what they can do. And usually those penetration tests are shorter in time. They might be more narrow in scope. That they might be general, but they're often, if they're general, they're often less thorough than a red team. Red team is usually internal to a company. So for example, you might have, like I might be a big company, I might have my own red team inside, and they are there to kind of instead of just kind of assessing the website, during a single engagement, they try to kind of, I guess, get in the heads of the attackers and kind of pretend to be that they're like this advanced persistent threat, and they're trying to, over the longer period of time, do some reconnaissance, do analysis of that network, and then try to exploit things more carefully, more methodically. Their objectives can also be pretty broad, or it can be pretty narrow. Like, for example, they might be testing a specific business unit at a time. In a lot of ways, penetration testers and red teamers share the same skill sets. But some people will argue strongly that they're completely separate job roles. But they share similar skills. Another job title I mentioned is bug bounty hunter. Usually, you wouldn't see that kind of role as something that that a company would that a general company would hire. There might be a company that like specializes in bug bounties, and maybe you can find a job that way. But usually, most bug bounty hunters are freelancers, contractors, and what they do is they generally kind of a lot of companies have published bug bounty programs or vulnerability disclosure incentives. So such that they have a policy on the website that says that if you find a vulnerability, we might give you this much money. And these are the websites, these are the endpoints that you're allowed to look at, these are the endpoints you're not allowed to look at. And so these bug bounty hunters, they kind of find these websites that have these policies. Most big companies have them, and their websites like Bugcrowd, I think, HackerOne, I think that they have listings of these programs, and they try to find vulnerabilities, and depending on the vulnerability, they might get a big payout. Some people who've been doing this for a long time can earn a lot of money. I would say most people who haven't been doing this for a long time probably will not earn a lot of money. And it's a very unstable job. It does sound very fun. And so I guess before I move off of the slide, I will mention that even though kind of these three roles are probably sound the most interesting, the first two, penetration testing and red teaming, probably the majority of your work is not going to be actual hacking. It's probably going to be just writing reports and documenting things and you know, providing guidance to the customer. And bug bounties are probably not as stable of a job, but it's definitely something you can do on the side. So something more on the defensive side, an example job role would be being like a SOC analyst. SOC stands for Security Operations Center, and that includes job tasks such as, you know, monitoring logs, monitoring network, you know, different security tools and infrastructure, to analyze alerts, you know, figure out what happened, and you know, identify and respond to incidents. The next few roles I'm going to mention, you know, are very, you know, can be similar in a lot of ways to being a SOC analyst. Different companies have different job descriptions that go with these roles, but in general, it means kind of monitoring the company infrastructure and logs for traces of malicious activity, identifying them, and, you know, passing them on to the incident response team or responding to them themselves. So threat hunters are I guess in some ways similar to SOC analysts, where they try to identify threats and vulnerabilities, but they're more proactive usually. So they kind of they analyze the suspicious activity. They and not only do they look what's happening internally to the network, to the company, you know, analyzing internal logs, they also monitor things like the dark web. They monitor public data breaches. They monitor emerging threats, you know, emerging vulnerabilities, you know, different attacks and attack vectors that have come up, and try to proactively figure out what those threats might lead to, and I guess direct the other teams of the company on how to prevent those threats. For example, you might have heard of terms like, you know, threat feeds, or you know, companies keep a track of malicious IP addresses that you know, have been known to have something, you know, have been known to have an attack launched from them or store some kind of malware. These IP addresses change every day, and so you might have some kind of threat hunting feed that you pull from to constantly block these IP addresses. And CrowdStrike, which is, you know, they were in the news a few weeks ago, or I guess a week ago, but they're really well known for their threat hunters. So another group of job descriptions is digital forensics and incident response. You know, sometimes you might see these as separate job roles. Occasionally, you might see them under a single DFIR role because a lot of the skill sets are similar. But in digital forensics, what you usually do is you analyze different artifacts, you know, network logs. You know, often if an incident already happened, you're trying to figure out what happened. You know, where did the attacker come from? How did they move through the network? How did they pivot? What did they steal? And so you start looking, analyzing. You start analyzing different malware. You start analyzing different traces that the attacker left. You know, they might be stored in, they might be found somewhere in memory. They might be found somewhere in logs. You might have to kind of piece a bunch of different things together. And so that's kind of forensics. And then incident response is, you know, very similar, where you also kind of take these different pieces of information, figure out what happened, and then also, you know, respond to the threat, contain the threat, and plan ahead. Kind of, you know, if a threat hasn't happened yet, what are you going to do if a threat does, if an incident does occur, and how you're going to recover from it. So there are also kind of there are a few more roles that are not like explicitly cybersecurity related. So for example, there are like you can be a software developer working at a cybersecurity company. So for example, you might be developing cybersecurity tools. You might be developing some kind of software that is used for, you know, say you work for Palo Alto and you're a developer. You'll be working on their firewalls, and you might or might not have to have a lot of background in cybersecurity. They're also kind of security architects. They're kind of often more technical. Maybe their non-cybersecurity counterpart could be like systems architect, where they just kind of design the architecture, but with security in mind. They perform threat modeling, which means they kind of assess, where data flows from, where data goes, where the data is stored, what's happening in these different stages. Is it encrypted? Is it passed securely? Whatever. And so they just kind of design the infrastructure. They just design the network, design the cloud in such a way that they're secure. So they don't necessarily hack the network, and they don't necessarily react to incidents that happen. They're just kind of the technical people actually building this infrastructure. Another example kind of role would be application security engineers. In a lot of ways, they are like web developers with a lot of experience in cybersecurity, and so they are able to analyze code that other developers have written to identify potential vulnerabilities, like SQL injection, cross-site scripting. They can also be the ones who create some kind of plan, or some kind of guideline for other developers to follow based on, like to follow secure coding practices and so forth. So even if you don't want to be, in a specific cybersecurity role, you can still be in a technical role that has something to do with cybersecurity. And I guess the last group of job titles that I'm going to mention falls under something called GRC, or governance, risk, and compliance. I think a lot of young developers and a lot of people who are first kind of getting into the cybersecurity field really have a negative reaction when they hear these things, because often, different security policies, compliance requirements, they're forced upon these developers and upon the company. They might be, first of all, burdensome, but also they might not be, might not actually have an impact on security. So you might have, like, let me see if I can think of an example. I don't know, I can't think of anything, but you might be required to do something that you don't think has any impact on the security of, of the company, but it's a requirement. And that, and there are a lot of different reasons for that. But I guess one thing is that usually if you're in a higher up role, if you do cybersecurity for a long time and you want to become a manager, usually you'll slightly pivot from a technical role to a less technical role, and GRC is where you'll inevitably end up. So for example, CISOs, a lot of them are technical, but a lot of them aren't technical at all. Kind of all they care about is just making sure that they look at the big picture and they try to understand, what are the risks. For instance, like they don't care if a website has some kind of specific vulnerability. They just care about, like, what are the chances that the website is being broken, and what is the impact if the website is broken into, and how does it compare to other risks that we have, and where does it make sense to invest more money? Like, does it make sense to fix our website, or does it make sense to fix our firewall? They kind of look at the big picture and try to make decisions that way. And so there are a lot of roles and job titles that fall within this. And so if you're, I guess, less technical, this could be a good area for you to be in. But even if you are technical, if you want to be in management, you'll probably end up somewhere in one of these roles eventually. So I covered some different job titles. And like I mentioned, there are a lot of them. The NIST NICE framework, I think, lists like 50, 52, 50 something different job roles. And there are hundreds more. So if you are interested in the field, you can definitely find something that kind of you can definitely find a niche that might be the most interesting to you. But also, even if you're not interested in cybersecurity as a career, you should still learn about it because it will make you a better developer. It can help you increase your salary if you have some skills that might distinguish you from others, and you might be able to work in multiple roles. And in general, it just improves the security of you know of of, of the company as a whole, of organizations of the country. If people who are writing the code are creating code that is secure by design. So now I'm going to talk about some different cybersecurity competitions. There are also a lot of them. So pretty much any job role that I covered in the previous slides, there is going to be a specific competition that like exposes you and tests you on the skills that are needed in that specific role. But here's kind of an overview of some of them. So many of you have probably heard of capture the flag competitions. There are generally two types. There's attack and defense, and there's Jeopardy style. Jeopardy style is the most common one. Attack and defense, I'll explain them more in the next slide. Um, some websites also list like HackQuest and Boot2Root as other separate types of CTF competitions. HackQuest usually means you just have, instead of having independent challenges that you solve, you follow some kind of scenario. Like in a cyber kill chain, you're trying to do some reconnaissance, you're trying to get initial compromise, escape privileges, pivot, and so forth. I usually see those as just a kind of a category within Jeopardy style CTFs. Another type of competitions might be inherit and defend. Some could say that it falls within red versus blue, but there are a lot of very popular collegiate level competitions that fall within this category. And what this format entails is you are put in the role of your team is put in the role of essentially taking over security team at some kind of fictitious company. You might be given 30, 40, 50 different machines that you have to protect. And you have, 1 or 2 competition days to do as much as you can. So secure the network, defend against professional red teamers in real time, write reports on what you've seen, what happened, fulfill injects. So for example, you're a security team at a business and there might be some kind of requirements from business, like you might have to install a tool, or you might have to do some kind of analysis, write some kind of report. And so that's where those injects would come in. But collegiate cyber defense competition is probably the most well-known inherit and defend event. It is national. There are like 7 or 8 different regions. And so if you're in college or if you're going to be in college soon, I definitely encourage you to check it out. I know a lot of people who have gotten careers, who have gotten job offers simply for participating in it, even without just showing up to an in-person event, participating in it. Even if they didn't win, a lot of companies really value that competition and the skills you learn through it. Another type of competitions is red versus blue. It's also a very broad category, but it can mean anything from, you might have heard of King of the Hill type competitions where your team is put into this network of 100 vulnerable virtual machines, and you and the other teams are trying to break into these machines and maintain access. It might be something purple teaming where you both defend your network like you would in an inherit and defend competition, but at the same time you're also attacking other teams. So I think red versus blue is just a catch-all for anything that's not CTFs. And also, like I mentioned, there are some specific competition. There are some competitions that cover specific job roles that I mentioned earlier. So there's there's CPTC, which is the Collegiate Penetration Testing Competition. There are multiple digital forensics competitions. There are like mathematics and cryptography competitions, for example, done by NSA, and there are a lot more. So going a little bit more in depth into capture the flag competitions, mostly because you're going to see these the most. So Jeopardy style is the most common one. If you've never done a cybersecurity competition before, Jeopardy style CTFs are a great place to start. And the way these competitions work is your team is given a list of, let's say, 10, 20, 30, 50 different tasks. Usually most of these tasks are independent from each other, and they cover a wide range of different categories. So some of the most common CTF categories are forensics, web exploitation, binary exploitation, reverse engineering, reconnaissance and OSINT, cryptography, and probably a few more. But what you have to do in those is you're given a list of challenges. I mean, I guess kind of similar to in a programming competition. They're just a bunch of different tasks where you have to do something, whether it's offensive, where you have to like break into a website and steal some data. It might be defensive, where you're trying to analyze a log file for trace of malicious activity. It might be something that has to do with math, where you're analyzing a encryption algorithm that is vulnerable in such a way that you can like brute force it very easily, or you can do some kind of known plain text attack against it. And the goal of each of these challenges is to find a flag. And a flag is just a string of text that you're looking for. It's usually in a specific format. And once you find it, you can exchange it for points in the platform. The nice thing about Jeopardy style CTFs is that they start out very easy. So starting with things like looking at different encodings. So you might be given a string in binary. And all you have to do is convert it from binary, and then you'll have the flag. A slightly harder one might be cracking a hash. You might have to pull out a tool like Hashcat or John the Ripper, take a word list and like actually crack the hash. You might have to look at PCAP files through Wireshark. In some web exploitation challenges, you might simply have to right-click and view page source, and you're going to see the flag there. It might be something where you have to perform a really complicated server-side template injection attack, and then use that to pivot and like exploit some kind of SQL injection vulnerability, through like SSRF. So the difficulty ranges, but they're a great place to begin. And as you participate more and more of these competitions, you will get better and better at solving these challenges and getting a lot of experience in the with skills that you will need in the job roles that I mentioned earlier. Another type of capture the flag competitions is attack and defense. I think currently, well, it's been pretty popular in the U.S. recently, but I think historically, I'm pretty sure it started in the U.S. and then it became really popular in Europe, and now it's kind of back, becoming more popular again. But attack and defense does require you to know programming, and it's less beginner friendly. But the way that works is each team is given a set of independent services that they're trying to protect. So, for example, you might be protecting a health portal. You might be trying to protect a bank, online banking app. You generally have source code access to these applications, and you have the ability to patch these applications. So what you do as a competitor is you look at these applications, you look through the source code, you find different vulnerabilities, you patch those vulnerabilities, you deploy the changes to production in such way that they don't break the functionality of the application. And then you use the vulnerabilities that you found while analyzing the application to steal data from other teams. And you have to write scripts to do that automatically because new flags are planted every few minutes. The scoring of it can sound complicated at first, but it's a really fun competition format. So if you don't know programming and you understand the basics of like web security, binary exploitation, I think you'll find these really fun. And like I mentioned, there's also HackQuest, ButcherBroot. I guess they're kind of Jeopardy style CTF, but maybe slightly more realistic and have multiple steps. So there are two kind of main reasons why you might participate in a CTF from like a skill learning perspective. One is to learn specific skills. So for example, if you're trying to solve a web exploitation challenge, you'll have to learn about like all the different types of web vulnerabilities there are. You'll have to learn about SQL injection and the different tools you might use to perform a SQL injection attack. You might have to learn about server-side request forgery, how to identify those attacks, what that means, cross-site scripting, different types of cross-site scripting. So as you solve these challenges and as you break into these websites, you gain exposure to a lot of these different topics. But also, if you're on the forensic side, you might have to use tools like Wireshark, volatility, Ghidra, to do something with a file that you're looking at. And CTFs are a great way to just kind of give you a bunch of these hands-on labs in a competitive environment that makes it fun for you to actually do these labs. Another reason is to learn the hacker mindset. There are a few, I guess often you'll hear people say, refer to like the original definition of the word hacker. And what they're usually referring to is not like breaking into the websites, breaking into systems and like stealing something, but more about just being curious and trying to understand how a system works. So for example, I guess hackathon, like the word hackathon, it probably uses the word hack in its kind of in its original sense. But it's not, it's something that takes a little bit of time to get used to. Like for example, if you're looking at a website, instead of simply looking at it as a user, and just trying to click some buttons and do things, whatever you need to do in this web application, doing these CTFs and getting into this hacker mindset will help you just kind of think through what happens when you do different things on the website. Like for example, when you click a button, what happens? Like, where does it do something on the client side? Is there some kind of JavaScript function that is run that does something? Is there a web request that is being sent to some kind of server? Is that server running Python? Is it running PHP? Is it running using some kind of like GraphQL, API? Just trying to find patterns and just trying to kind of think about how things work instead of just using them. And CTFs and cybersecurity competitions are a great way to learn that mindset. So another reason, if you're trying to be good at security, you need to have a pretty good in-depth understanding of a lot of different things, because in order for a system to be secure, it needs to be secure at every level. So for example, if we're talking about a website, there can be a vulnerability, in the application level. So somewhere where you have some kind of flaw in your code that maybe like a logic error that if the user does something in a specific order, the website is going to break and maybe reveal some sensitive information. There might be a vulnerability on the software level. So for example, you might be using Python, or you might be using like the Apache web server to host your web application. And even though your code is secure, there might be like a 0-day vulnerability in there. Also, Apache, whatever the software runs on top of an operating system. So you have, Windows, Linux, Mac, whatever. They have their own vulnerabilities. And then you get to the network level. You might have a vulnerability in how the packet is sent and intercepted. Hardware. There are a lot of different areas where there can be vulnerability. You don't need to have you don't need to have in-depth knowledge into all of them, but you need to kind of understand, I guess, in general, how these things work. And one of the best ways to learn this is by trying to break the system. And CTFs are, a great way to do that, because that's kind of the point. We give you systems that are vulnerable by design, and you have to break them. So why would you compete in competitions, in cybersecurity competitions, and programming competitions? First of all, like I mentioned, you learn hands-on skills. You can gain exposure to different job roles. So for example, if you are, in particular CCDC, you have to take on the role of a system administrator, of a SOC analyst, of a penetration tester, report writer. Like there are a lot of different roles that you have to take in these competitions. And over time, throughout college, maybe through the different years that you participate, you will kind of find the area that you're the most interested in. And so participating in these different cybersecurity competitions is a good way to expose yourself to that. Um, a common skill that a lot of developers and security professionals and just technical people lack is soft skills and the ability to work in teams, to communicate. Um, you know, Probably one of the most important skills you will need in order to advance in your career, to move from like a developer to manager, is being able to communicate, explain your ideas, work well in a team. And um, often that might be hard to find in college, but these competitions, they force you to work in teams. I used to share this story a lot, but when I was at UVA, my team won the National Collegiate Cyber Defense competition, the first time we ever participated in it. So we went in not pretty much not knowing how the competition runs, and we were competing against these teams that have been doing this for years. And I think kind of the main reason, what we attribute to the reason of why we won, is because we had a really good team. A lot of us, we definitely weren't the most technical team, but we didn't freak out under pressure. We um, were able to kind of communicate clearly. We're able to kind of keep our cool and make sure that all the parts of all the tasks that we had to do were completed. And I think just because we had fun doing this competition, um, that helped us win. And so, um, yeah, communication, working in teams, competitions are a great way to learn that. Another reason you might want to participate is because it's a great way to meet people. A lot of security conferences, so whether you're local to like the Nova area, or if you're international, you'll often find like a B-side security conference, some other kind of security conference, developer conference, happening within your vicinity. A lot of colleges host their own competitions. GMU hosts Patriot CTF. Virginia Tech hosts, I think, Cyber Summit CTF. Thomas Jefferson hosts. Well, I think you still do, but it used to host Thomas Jefferson CTF. UVA hosts one. That a lot of colleges have student groups that run these competitions, and so wherever you are in the world, you'll probably find one close to you. And by going to these competitions in person, you get to meet other people who are interested in working on the same things as you, but you also get to meet recruiters, because often these competitions have sponsors who are desperately looking to hire people with skills. And by coming to these competitions, you kind of self-select in a way, by demonstrating that you really have the interest in these topics. Also, a lot of security conferences have free tickets for students. For example, ShmooCon is a really well-known conference. Unfortunately, I think 2025 is going to be the last year it's ever run. But if you submit an application, they will give you a free ticket, and they'll even pay for a portion of your travel costs to get there. So, participate in competitions, and if you can find a local one to go to with your team, definitely take the opportunity to do that, because um, you'll definitely learn things in college, but most of the things that you'll learn that you'll probably end up using in your day-to-day job will come from these competitions. And I didn't mention it earlier, but yeah. So during my college, UVA is a great school, and I learned a lot. I learned some very niche things about operating systems and computer architecture, but a lot of those things I don't use in my day-to-day job. Pretty much everything I've learned has come through these interactions with other people, by going to these conferences and learning from other professionals, by placing myself in these simulated environments and in these competitions. And so definitely another reason why you should go. So here's a list of a few competitions that you might find interesting. So Cyber Patriot is a middle school and high school level competition. It's organized by the same people who run the Collegiate Cyber Defense competition. And so you're usually given a set of virtual machines that you're trying to analyze and find misconfigurations, find malware, find some vulnerabilities, security, I guess, emissions, and fix those. I did it all 4 years in high school, and I definitely learned a lot through it. CCDC is open to college students. There are, I think, the United States is broken up into different regions, and so whichever college you go to, will be part of a region or the at-large region. But CCDC is probably the most well-known cybersecurity competition among cybersecurity professionals. And so you should, if you're really interested in this field, even if your school doesn't have a team, look into starting a team. Pico CTF is a capture the flag competition that is beginner friendly, and it's a very good competition. And I think only high school students are eligible to win prizes, but it's open to anybody. So even if you're not a high school student anymore, you can still participate. You're not going to be able to win a prize, but it's a very good beginner CTF. ISTS is run by Rochester Institute of Technology, I think every spring, and it's kind of similar to CCDC, but it has some other, I guess, offensive elements to it as well. DOE Cyber Force, very similar to CCDC, but run by Department of Energy. National Cyber Cup. I forget which one that is. So I think it's run by maybe cyber.org, but it's I think it was meant to be a kind of this national cybersecurity competition. NCL is run by a company called Cyber Skyline, and it stands for National Cyber League. So I think every semester they have, I'm not sure how they still do it, but every period they have essentially a season where a lot of students compete, and in a capture the flag competition, they gain points, they move on to the next level, and it's a well-known national CTF competition as well. So the U.S. Cyber Team, I think it's open to anybody under the age of 26, but it's every summer. It's there's a competition called the U.S. Cyber Games. It's sponsored by CISA, by NIST, by a lot of government agencies and a lot of companies in the industry, and they get a lot of participants, and from those participants, they over the course of the next several months narrow them down to like 15 or 20 cyber athletes who are going to represent the United States in different international competitions. So, for example, there is the International Cybersecurity Challenge that's done every summer or fall. 2 years ago it was in Greece. Last year it was in California. I think this year it's going to be in Chile. But it's an international competition where they have a team from every continent, and they compete to win the international cybersecurity competition. And they also go to some other international events. For example, I think this year there's going to be the European Cybersecurity Challenge. I'm not sure where it's going to be, but it's somewhere in Europe. And so if you want to be part of that team, you should look into U.S. Cyber Games. And like I mentioned, there are a lot of local events that are happening as well. So some other resources you can take a look at. If you're trying to gain skills continuously, instead of participating in specific CTF, try HackMe, Hack the Box, and there are like, if you look up war games, there are a lot of different services that just have open playgrounds with these where you can learn new skills. My team, we run monthly mini CTF competitions. So our next one is going to be in August. I think Thursday, August 22nd at 5 p.m. Eastern. So it's only going to be 5 challenges. Usually 1 or 2 of those are very beginner friendly. So if you've never done a CTF, it's a great place to start. And all of the solutions for the previous competitions are published online. So if you're you can go to like the July, June, May CTFs and look at those challenges and solutions to gain some practice. And if you're interested in the cybersecurity field, I encourage you to look at this booklet that was published by our friends at Black Hills Information Security. It covers a lot of different cybersecurity careers, different topics, and gives you tips and kind of suggestions on the things that you can do to get a job in the field. It's a really good resource, and you can find it at this link. Yeah, and I guess the last resource I'll mention it's called CTF Time. I think it's hosted at ctftime.org. Let me see. Yeah. And essentially it's just a list of all of the different upcoming CTF competitions. Some of them are really hard, some of them are easy, but if you usually find the ones that have a lot of teams that are going to be participating, and it has a relatively low weight, then those might be good beginner ones. But you can see, for example, Patriot CTF, I mentioned it earlier, but it's run by George Mason University, and it's a really good competition. And there are a lot of other ones. FOSS CTF is an attack and defense competition, as opposed to Jeopardy style. So yeah, definitely take a look at this list, and see if there are some that you can participate in. Yeah, well, thank you for joining the talk. That's it for me. So I'm happy to answer any questions. I want to once again congratulate all the participants for competing. I'm very approachable, so you can send me an email. You can send me a message on LinkedIn, and I can if you want this slide deck, or if you want me to share some of the links that I shared earlier, or connect you with like our UVA cyber team, or give you some suggestions on how to start a cybersecurity team at your college, I'll be more than happy to talk to you. But yeah, are there any questions? And I suspect there's probably a delay. Yeah, go ahead.
Yeah, thanks so much for like your presentation. We do actually have like a few questions for you. So I guess the first question here is, you mentioned like in like cybersecurity competitions, like you mentioned like a lot of different categories in terms of like, for example, CTFs, like there's a lot of different like categories, right? Would you say like any like different categories are like more applicable in like real world scenarios, and like why?
Yeah, so let me find the slide. So looking at the different cybersecurity competitions, I mean, probably the most real world ones are going to be the inherit and defend ones, because the entire premise of the competition is that you're put in, you're replacing a security team in a company, and you have to secure the network, protect it in real time against attackers, and you have to write reports. So I would say this, but also if you're interested in a specific role within cybersecurity, for example, penetration testing or forensics, then usually kind of these more niche competitions are also going to be pretty relevant. CTFs are probably slightly less realistic, but they are a great way to learn skills. Like for example, for these competitions, you need to prepare for them a lot. You need to have a plan coming in. You have to have practiced a lot. CTFs, you can come in with zero preparation, and you can learn a few skills here and there. Yeah.
Okay, I see. So like specifically inside like capture the flag competition, since like I think a lot of people have heard of those before, right? Like other like categories such as like the ones on your slideshow, web forensics, like reverse engineering. Would you say any of those are like more commonly seen in like when you're trying to like, you know, find vulnerabilities or like defend something?
Yeah, I think it depends on the job role. I think all of these can be pretty relevant. I would say that for most developers, usually web exploitation is probably the most. What happened? For most developers, web exploitation is usually the most relevant category. If you, I mean, but binary exploitation is pretty niche, and like exploit development, malware research, there aren't that many people who do it. But for example, these two categories will be very relevant for them. Forensics, if you're doing anything on the kind of defensive side, so usually the tools that you would use in the forensics category, you'll probably use in your job. But I'd say that for most developers, for most kind of, I guess, penetration testers, if you want to be a bug bounty hunter, usually web exploitation category is probably the most relevant.
Okay, that makes sense. So our next question here, this is so, you know, in the modern day, like we have a lot of new emerging technologies, like people have like quantum computing and AI. Do you think any of these will like impact the future of cybersecurity careers a lot?
Yeah, I think they definitely will. For a long time, I used to kind of roll my eyes when people would say AI because it, you know, it's such an overused. It's like a buzzword. So like, you know, blockchain used to be a big thing. I mean, it still is, but for a long time, I used to see kind of AI the same way. But recently, I've started seeing some of the things that LLMs and AI can do in terms of kind of solving these really complex security challenges that we give to humans. AI can do this pretty easily. And so I think it'll definitely have an impact. You know, there is so much data that's going through so many logs. You know, in the past, people used to be able to, a company might have had, say, 10, 20 servers, and they could reasonably manually look through the logs and find, you know, things that look out of place. But nowadays, you know, a system might have 100,000, you know, a million different machines and containers, each of which produces its own logs and data. And so being able to parse through that, I think AI, for example, it could have a really big impact. But pretty much, you know, in any of the roles I mentioned earlier, I think a lot of those could be aided by, partially replaced by AI. And so, but there's always going to be some kind of, you know, fighting back and forth where one side will develop a really good offense tool, and another side will develop a really good defense tool. And so I think humans will still be needed.
Oh, okay. So earlier you were talking about how your team won like a cybersecurity competition when you participated for the first time because you like worked well together as a team. Would you say like when you're participating in these sort of cybersecurity competitions, are there any sort of specific like strategies or techniques that like help you work together as a team?
Yeah. So for, I mean, I think the biggest thing is stay calm under pressure, because these competitions can get really stressful, especially if you're, you know, moving down in rankings. It's very easy to blame somebody for something that might have gone wrong, and so avoiding that completely and staying cool under pressure, understanding that's a competition, I think is a really big skill. But also just preparing ahead of time, having a plan of which person is going to do what in the competition. You know, whether it's CTF, you know, we might have some people immediately start working on web exploitation or binary exploitation challenges. Whether it's CCDC, you know, you might have people focusing on Windows, some other people focusing on Linux, some other people focusing on the network. So practicing ahead of time, figuring out a playbook, and dividing roles and responsibilities. I guess specifically for CTFs, it's nice to have some kind of Discord server where you can maybe create a separate channel for every challenge that you're working on. It's nice to have some kind of like a virtual machine ready, some shared resources that you can both access, whether it's node sharing, password sharing, just kind of, you know, preparing your tools so that you can jump right in.
All right. That's our last question. So thank you so much for coming out again, and we really appreciated you being here today. Additionally, we're also now happy to announce that we have a second guest speaker here.
Hello, this is Zhen Qian, and he's the Vice President of Generative AI Services at Oracle, and he's a seasoned executive with over 25 years of experience in pioneering technological innovation in AI and machine learning, with a track record of steering world-class engineering teams at global tech giants like Oracle, Microsoft, and Amazon. He has proven expertise in executing ambitious AI initiatives, driving strategic partnerships, and propelling organizational growth through cutting-edge research and development. Now I'll hand it over to Dr. Xian. Please ask him any questions that you have in the YouTube live stream. Thank you.
Hey, thanks, Eric, and hello, team. And first, make sure you guys can see the slides on the screen. Yeah. Great. Okay.
Assume that.
Okay. Yeah. And my name is June, and I work in the field of AI for a really, really long time, right? And I think more than 30 years. And today I'll be talking about, one exciting areas, right? And I think everybody already know, right? And generative AI, you probably heard the name quite a lot recently in the news. And today I will focus on two models, right? Because there's so many areas in generative AI, right? And I want to focus on two models, right? And one is called the transformers, and another one kind of diffusion models. And we will do some codings, right? And I assume this is organization, right? And related to coding and computations, right? Yeah, we'll definitely dive into codes, right? And not only talks. Okay, great. So let's move on to the next slides, right? And this is more about the background slides. And you probably heard AI and machine learning quite a lot, right? And these days, in the high level, right? And AI captures the overall field about create machine intelligence, right? And which can help, right, human, and in certain tasks can even match human, right? And like AlphaGo. And machine learning is a very specific sub-area for AI, right? And which we learn specific patterns, right? And from the data. And another topics, right? And is what is the difference, right? Between the traditional programming versus machine learning, right? And will the machine learning eventually, right? And replace all the programming, or it's just complement for each other? And I think, right, and we can have a little bit more discussions, right, and after talk. So let's dive into the first topic, right? What is generative AI? And in broader sense, right, and it's AI technology, right, can create new content, such as image, music, text, or even videos. And by learning all these patterns from existing data, and I assume, right, and most of you have already used ChatGPT, right? And maybe you can raise a hand. I don't know. I'll see how many people, right, have used the ChatGPT. Oh, how do I see the audience response somewhere? Yeah. Just one person? Okay, yeah, and I don't know if you guys have heard of, for example, Stable Diffusions and Sora, right, which is video generation, right, and Suno, right, which is music generation, right. And again, we'll cover some of the fundamental technologies, right, and how this generative model works, right, in the real life. Okay. So transformers, right? And the transformer was originally started from the Google research, right? I think the one paper published on the 17 or 19, and is one type of the models, and which can generate sequence, and from the sequence. We call it sequence to sequence task, right? Basically, the model can learn from all the text, right? And any of the books, public internet, right? And the model can learn from what we call it, and all the text archives, right? And can learn to do a lot of sequence to sequence tasks. And one example is language translation. And the transformer is capable and can do all the language translations, right? English to Chinese or English to Spanish or vice versa. And another capability is we call it task summarization, and give input of a paragraph of the sentence, right? And the model can summarize all the content. And another one is chatbot, right? And a lot of folks you probably already use. If you use ChatGPT, it's one typical of the chatbot, right? And basically you can ask any question of the chatbot. And you probably heard a lot of similar products from Meta AI and Google Gemini, right? It's all type of chatbots. And all this kind of technology is based on the single model, right? We call it transformers. So for the transformers, right, there are a few key components, right? And one is the encoder and one is the decoder. And the last one is attention mechanism. So you can think about the encoder is a process, right? And we encode all the input data, right? And in this case, right, and in the original paper, it's a text. However, right, and you can also imagine, right, and the encoding can also do, for example, voice data and image data, right? We have this called encoder. And the decoder is really that generates the output, right, and from the hidden space, right, and encoded by the input data. Attention really is the maximum. How do we match and how do we focus on different parts of the input, right? And if the input is really, really long, right? And how can we focus on different parts of the input streams, right? And this is called attention mechanism. It's another key technology as for the transformers. And this is a little bit abstract, and however, let's get into a little bit detailed coding. And so this is end-to-end examples, right? And for a transformer, right? And you can run the code, use the Python notebook, right? Install certain libraries, right? In this case, right? And we load a model, right? And from the Hugging Face, and we have a tokenizer, right? We have model. And so it's very simple steps, right? And we're using tokenizer, right? Token, so basically convert this to token. And then we pass the token to a model. And then we're using tokenizer to process the output. And then we can print the translated text. So this seems very abstract. However, right, if we take a look at the real code, right, and I have the code load in the Python notebook, right, and we can take a quick look. So this is identical code, and I just showed you guys on the slides, right? And same thing, we load the model here. Here, I load an English to Chinese translation model, right? And put a sentence here, right? And after I run this, it will get the translation, right? Let's give it a quick run. And you guys can verify if it's the right thing, right? And of course, right, you can switch to Spanish model, for example, right? And if we switch this to Spanish model and run the same again, yeah, you can see it's very easily, right? You can translate to Spanish, right? You guys can verify. I don't really know Spanish, but you guys can verify if it's the right translation. So yeah, so transformer is really, really powerful, right? And almost every single application you saw today in the world, no matter the ChatGPT or Meta AI, is all powered by the transformers, right? And you definitely want to at least know this terminology, right? What is transformers? It's one sequence to sequence, one type of models, right? We call it sequence to sequence models, and can generate text, right? And we can continue to see another examples, right? And in addition to translations, right? Transformers also capable of a lot of things. So you can also, using transformers, do creative writing, right? For example, write a joke, for example, right? And I will show you another example here. So in addition to a translation, right? And let's take another examples. Yeah, here I will load another model. It's a really big model, right? And it's one of the Llama 7B models, right? Created by Meta. it's probably going to take a while to load the model, right? I have a local GPU in my machine, right? So I load the model in the memory, and I print out the model architecture, and then I'll try to generate a joke, right? So I write a joke about.
Hi, Dr. Chan. We're actually not able to see the model.
Oh, sorry, you were not able to see the code. Oh, that's right. Sorry. Let me see if we can switch to the screen. Okay. Sorry. Let's switch to. I think this is the screen. Share. Okay, let me switch to. Wait a minute. Oh, I see. They can only say specific type. Okay, just give me 1 second. Let me switch to this screen. Present. Share screen. Okay. Okay. This should work, right? You guys should see this screen. Okay. Sorry. Yeah, I'll rerun the example, right? First example is translation, right? So yeah, let's go back to here. So first way we'll run is English to Chinese translation, right? Using transformer, right? Okay, so you saw the translation. And a second example I was showing is the translation. Instead of the English to Chinese, I load a model, another model, English to Spanish, right? And I rerun this code again. So this is English. Again, the code is very simple, right? And basically, you put the model name here, and you have a tokenizer, right? Tokenize the input at its input strings, right? And then you send its encode strings, right, into the model, right? And the model generates the output. Okay, so this is one example, right? And using transformer into the translation. And I was going to show you another examples, right? In this case, I load a little bit bigger model, right? And it's called the Llama 2 model, right? Which have 7 billion parameters. And I load these models, right? And into my local computer. And then I was trying to write a joke, right? So let's say write a joke about this foundation, right? Let's see what it's come out. Oh, this is like, okay. Let's try another one. Is this? Oh, this seems like a Spanish. Okay. Let me try to reload this model again. Load this model. Okay. The model here. Okay. Okay, this time it take a while and see what the output. Yeah, the model is really large, right? 70 billion models, right? And it's running, right? It may take a while, right, to generate the output. Right? That's one of the challenge, right? And for the larger, we call it deep learning or transformer models, it take a lot of the memories, right? And it may need a special process unit, right? In this case, it's a GPU, right? You heard NVIDIA stock is going super high because they are pretty much the only GPU vendors, right? And the industry that provide all the GPUs, right? And to the other companies. So here, yeah, one is output, right? Basically, so transformer have a lot of capabilities, right? It is one of the most powerful machine learning models, right, in this world. It's power a lot of things, and so in this case, I just show you two examples, right? One is using One is doing the translation and another is doing generation. However, you can using your imagination, right? And transformer is capable to do a lot of things, right? And it's already power a lot of applications, right, in this world. So it has a huge impact for the industry as well. So that's one of the very basic but powerful models, right? And let me go back to my original slides. Oh, one more thing I want to show you, right? So another thing I mentioned, right? And the typical transformer models actually have three key components, right? One is the encoder, one is the decoder, one is also we call the attention layer. So I will print out the model architecture, right? The first translation model, right? Give you some ideas. If you look at this model architecture, I will just give you the rough idea, right? So it has an embedding layer, right? Basically convert the embeddings, convert the input stream into the embedding space. And then they have this, yeah, so basically, so let me reload this. And I'll print this again. Okay, so if you look at this translation models, right? It has an encoder, right? Encoder and also have a decoder, right? And if you look at these encoders, if you're familiar with this Python language, right? It basically showed you, right? We have a multi-layer of this encoder models, right? In this case, we actually have six layers, right? And for each of the layers, right? And we have a lot of attention, we call it attention block. So it's a fairly complex models, right? You can think about, right? And 6 layers, each layer have very complex the architecture, and then we also have the decoder layers, right? Decoder component, right? We have encoder and decoder, right? This is one of the transformers, right? In this case, and used for the translation models. However, for a lot of modern models, right, and it may only have the decoders, right? I will give you another example, right? An example like this one, right? This one only have decoders, right? But again, it's a very deep network, right? If you look at this, right, actually have a 32 blocks, and each block, right, and have a multiple components, right? And this is only, we call the Llama 2 model, is relatively small model. It's like the model is equivalent to the GPT model, the GPT-2 model, right? And which OpenAI launched in 2018. So you can imagine, right? That was a model developed about 6-7 years ago, right? And in these days, right, the latest model using the ChatGPT is much larger, right? And the model I mentioned is 7 billion parameters, right? And however, right, and of course, OpenAI didn't tell exactly how big is the model, but based on other information, right, and the industry guess, it could be 1,000, at least hundreds times bigger than this model. So you can imagine how big of the model is, right? It's a super big model but super powerful as well. Yeah. Okay, let me stop sharing on this. And let's go back to my original slides. Okay, so that was a transformer, right? And this is one of the foundation models, right, or cornerstones of all the generative AIs. And most recently, right, and we also saw a lot of the image generations. For example, if you're using DALL-E or ChatGPT, right, you can actually generate image, right? It give a very simple text descriptions, right? You can actually generate image. So it's quite amazing. And one of the foundation models, right, and to power this technology is called the diffusion models. So this is relative new technology. It's getting really, really popular in past 4 or 5 years. And you probably also heard, for example, Sora, right? And it's one of the latest video generation tools, right? And from OpenAI. And it can generate, for example, right, and 10, 30 seconds videos, right? And just based on the text prompt. And diffusion model is also, right, and powering the video generations. There are many, many other companies, right, and doing video generations, right? And diffusion model is one of the very powerful, but also, right, and foundation technology, right, for all these companies. So for the diffusion models, right, and it's actually borrowed the concept, right, from the physics. And you can think about, right, there's a two process, right? And one process we call the forward process. So basically given an image, right, and we try to add a noise to this image, and eventually it's become a pure noise. And then we also have a reversal process. Basically, we're trying to remove the noise, right? And step by step, and eventually, right, we can restore the image, or we call generate the image. So, and I'll give you a little bit more examples right later. There's some key component of a diffusion model, right? And first is a noise scheduler, right? Basically, it's a sequence of the noise, right? And we add into the real data. And the model training as well as the model prediction process, you can think about is, right, giving a purely noise image, and we can generate a real image, which we have not seen before. And so that we call that a denoising process, right? And of course, right, and how the machine learns, right, we need to have the loss functions, right? Basically, and we need to know if the image generated is good or not good, right? And so basically we call the loss, right? And if this model is good or not good compared to the real image. And I will give you more examples, right, and in the later. So how the diffusion model works, right? And as I mentioned before, right? And so think about this, right? Even as a human being, right? And if you saw, let's just take a car as an example, right? If you saw a lot of cars, right? And you clearly know how this car looks like. If I tell you to draw a car on a plain white paper, so essentially you are generate an image right from nowhere, right? And so you can think about this, right? Your brain already learned how this car looks like. And then when you're trying to draw a car, you essentially, right, generate this image, right, and from your brain. But no matter how good you are, the car you draw on this paper may not be identical to any car you saw before. So you can, from the mathematical perspective, you can think about it. You actually draw a sample from this car distribution. So that's the key concept of the diffusion. So basically, and the diffusion can learn this distribution, no matter in this case a car or human face or anything. Right, so the diffusion model is really good to learn this distribution. The generation process is essentially a sampling process. Right, once we learn this space, we can just randomly, right, and pick a noise, and then we can generate image, right, from this sample space. So that's a high idea of the diffusion model. Again, this is still very abstract, right? And let me show you some code, right, and help you to understand this process. So let's switch first, right? Let's talking about the forward diffusion process, right? So I talk about the forward diffusion process. I think probably still very confused to a lot of people. Yeah, let me show you one example here. First, let's look into the forward diffusion process. So the forward process, essentially in this case, and I want to show you is, right, and we will load the image, right, and from a local disk. Or in this case, I just load an image of Einstein, right, and then I will gradually add a noise, right, to this image, right. So basically, we need to create a scheduler, right. In this case, scheduler is nothing, right, just 1,000 steps, right. For each steps, we will add a noise, right, to this image until this image become a purely white noise, right? And I will show this process here. So this we call a forward diffusion process, right? So we load image, right? In this case, Einstein, then we continuously to add noise, right? And into this image, right? Until it becomes, after 1,000 steps, right? Because you keep adding noise, right? After 1,000 steps, it become a pure noise, right? In this case, right? This is what we call a forward diffusion process, right? And from step 0 to step 100, you saw we get add more and more noise, right, into this process. And in the next step, right, and I will show you the reverse process or generation process. How can we generate an image, right, and from this noise? Okay, so this is the code for generation, right? In this case, right, of course, right, and we don't have time, right, to retrain the model, right? And so training the diffusion model could take days or even weeks, right? Depends how big is the model, right? And this is one of the model pre-trained by Google, right? And using the celebrity data set, right? So I already preload the models, right, and in my computer, right? And in this case, right, and we'll show the generation process, right? And so let's run it first, then we'll explain the code, right? So in this case, right, you can see, right, the input is pure noise. However, after the 1,000 steps, right, it's a reverse process, right? And after 1,000 steps, right, and we see a real image. However, this is not any person in this world. It's purely generated by the computer. And if it run again, and if it'll give you a different image, again, this is purely generated by this model, right? No such person in this world, right? And you can keep doing this, right? As you mentioned, right, the model already learned the human face, right, as part of a training process. The generation is essentially a sampling, right, and from this space, right? And if you read the code, right, the input is pure noise, right? The Gaussian distribution, right? Pure noise here, right? And we have input, and then we have this what we call the reverse process, right? Essentially, right? And we trying to denoise, right, from this space. Basically, what this diffusion model do is every single step in trying to predict what is the noise actually, right? And then we remove the noise, right? And then we get a little bit of better picture. So this is called a denoising process, right? After 1,000 steps, right? And then we can generate a pretty realistic models. That is the power behind a lot of state-of-art diffusion models, right? When you using and all the image generation tools, right, or even video generation tools, it can generate amazing videos and images, right? And however, right, and the image, right, it's not real, right? It's not real people, right? And you never saw that before, for example, right? Because it's purely generated and by the computer. Yeah. So yeah, that's one of another powerful model, right? Diffusion models, right? And let me go back to my slides again. Okay. Okay, yeah. So yeah, so that's the diffusion models, right? And we just showed, right? And again, as I mentioned in the beginning, right? And diffusion models is super, super powerful, right? So it can not only generate image, and we already have a lot of successful companies, right? OpenAI, Midjourney, right? Very successful companies, right, in doing the image generations. And also audio generation, you probably heard of Suno, right? And which can generate, you can go to suno.ai, right? And you can type in some text, it can actually generate music as well, right? Quite amazing. And video generations, a lot of companies already work on video generation. Sora, Runway, and Pika. Pika you probably heard, right? And two PhD students from Berkeley, right? And they just started a company less than a year ago, right? And so that's Pika. However, the technology using the behind the scene is diffusion models and of course transformers. Both transformer and diffusion models are the key technology behind all these big companies, big and small companies, very amazing and technology, right? And behind all the generation companies. Okay, yeah, we already showed the model, right? Diffusion models, right? And yeah, that is my talk. And I think these are two models, right? We use every day, and I hope, right, this give you a sense, right, and how the generative AI works, right? It's all about coding, right? It's nothing magic. Essentially, it's all the coding and behind the scenes, right? And hopefully, right, this give you some of the idea, right, and how this big company and a small company, how this amazing technology works, right, behind the scene. Yeah, I think that's for my presentations, right? And I'm open for any questions, right, you may have.
All right, thank you for the talk. So, one question that we had, which is just pretty general, but seeing that you have like a lot of experience, like how specifically do you think like the role of generative AI will like play into basically just like the general business scheme for like a lot of tech companies and also just like the world in general?
Yeah, I think generative AI, as I mentioned, right, can do a lot of things, right? And so, I use the generative AI technology every day. For example, right, before like you do grammar check, right, and it's very simple, right? Start from grammar check, right? Start even the slides, right? I can even prompt the ChatGPT, right? So let's say if I want to prepare slides or prepare a topic, you can do a lot of brainstorming, right, with ChatGPTs, right? Of course, for business, right, you can imagine there's a lot of business, it's a lot of fundamental use cases, right? And we had before, right? We cannot solve. Now, generative models actually can do really, really well. For example, even classifications, right? If you want to classify a text, for example, if you have Twitter feed or X, which we call X feed, right? If you have message, right, you want to classify if this is some violence language, right, or is some other and language that you want to classify the message, you could use generative models, right, do the classification in this case. So yeah, generative model and can solve a lot of problem and also create a lot of opportunities, right? And for example, all the code I showed you today actually is generated by generative AI. So all the code is also generated by generative AI. So you can imagine, right, in the future, right, I would say, majority of the, a lot of code will be generated by computer. And so as a human, right, and we'll work together, right, and with AIs, right, to make it better. Yeah.
All right, thank you. And then another question that we had was like, you talked a lot about basically just generative models and their ability to basically just generate like art and also like videos.
Mm-hmm.
So how do you like specifically think that like this could like what are your specific thoughts on how this could like affect basically just like general artists and also just like the copyright issues like or creativity issues behind like using generative AI for like art now?
Correct. I think this is a broad topic, right? For example, Suno I mentioned, right, actually is already sued, right, by some of the music recording companies, right? OpenAI also have some of the discussion, for example, with New York Times, right, to have their content licensed, right? And I think, right, and technology will always moving forward, and however, regulation will go along with the technology. Right. So I think in this case, right, and we can think about it, right, and for example, right, and a lot of artists are actually using the Mid Journey and the DALL-E, right, and generate the image, and you can imagine, right, and not far along, you can imagine, right, and how the movie industry, music industry will be dramatic change, right, and you can imagine, in the future, right, you may not need a movie studio anymore, right? As long as you're a good writer, right, good directors, right, you have some ideas, maybe in 10, 20 years, right, you just need to have some great ideas, right, and everything will be generated, right? The whole movie, whole music will be generated, right? Of course, right, along the way, right, have a lot of the copyrights, right, and other things. However, think about the human history, right? And technology always moving forward, right? And all these regulations, right? And we will figure out, as human will figure out, right? Just like we invent the car and then we invent all the traffic rules, right? We will figure out how to regulate all this technology. And however, and thinking in the long term, right? Thinking about, okay, in 10 years, 20 years, right? And you can imagine a lot of this works, right? And it can be automated, right? It doesn't mean, right? And human have no role here, right? And then we can spend more time to be more creative, right? Transformer is the model invented about 7 years ago, right? Diffusion model, it was actually a pretty old model, right? I think more than 10 years ago, but it has been used, right? And most recently. However, the deep learning technology itself, right, and it's about 40 years old, right? And but this is just the very beginning of the AI revolutions, right? You can imagine, right? We'll have more and more advanced models, right, and advanced technology, right? And I think we're just in the very, very beginning of the whole technology, right? And I think it's a huge opportunity for you guys, right? I think that this is a great time as AI practitioners, right, we have been working with AI for the 30 years, right? We are lucky enough, right, to solve these revolutions, right? First, we saw the AlphaGo, then we saw the deep mind technology, right? AlphaGo and other technology, and then we saw the transformer, right, and the ChatGPT, right? I think this is tremendous opportunities, right? And as we look forward, I think there's just tremendous things, right? And we can work on that. I'm more focused on the technology part, and however, it doesn't mean right technology only things, and technology is really driving all these revolutions, right? In the past, I would say 10 years, like deep learning revolutions, and it's driving the change, right, for the whole society, right? And it's plenty of opportunities, right, and for us to understand the technology. So I think, well, when we're talking about the regulations and other things, I think number one thing is, right, as a technical person, right, as a programmer myself, I think number one thing is really understand the technology. Right? If you don't really understand technology, you'll be influenced by all the medias, right? You're influenced by other folks, right, who don't even know how transformer works, how diffusion model works. By the end, it's still the coding, right? And it's nothing magic there. It's not some crazy AI machines there. It's all the code, right? And you can use the code to control pretty much everything of this model, the output of the model. Yeah.
Yeah. Okay. Thank you. And then another question, like you said, you had like a lot of experience, like basically just leading innovation in AI, right?
Mm-hmm.
So what do you think is like the most challenging or like underestimated like aspect of like doing this, and like how have you basically like navigated through this in your career?
Yeah, I think number one thing is to keep learning, right? And I have to read a lot of papers, writing a lot of code today, right? Every weekend I read a lot of these blogs, code, YouTube, right? And writing all the code myself. It's just a learning process, right? Because technology, especially in computer science, AI, and keep growing, right? Every single day. So have a degree is just very beginning, right? And I started writing code when I was 13, and after 30 years, right, 40 years, right, I still like writing code, and it's just a learning process, just like reading books. I think number one thing for me, I still keep learning, right? No matter what degree you get, right, you get a bachelor, master, even PhD, it doesn't mean, right, you stop learning, right? Because as I mentioned, right, the diffusion models, it's just getting really popular in past 2 years. Transformer just getting very popular, I would say, in past 5 years, right? No matter how high the degree you get 5 years ago, is irrelevant, right? You still need to keep learning. I think number one thing is keep learning, right? Don't limit yourself, right? And no matter how high you are, right, and your degrees or your official titles, right, LVP title, it doesn't mean it's in front of knowledge means nothing, right? You always need from the scratch. You always need to learn, right? And what is transformer, for example, what diffusion model, what is generative AI? So it's all technology, right? So I think we should always be humble, right, and to learn things, right? And as we are kid, right? And when I was a kid, right, I was always curious, right, to learn new things. I think that's the same as today, right? And I still keep learning new things every day.
Yeah, okay. That sounds great. And then another question that we had is like, what do you think like the most challenging like aspect of like basically like integrating like generative AI has been for you specifically like in your company? And do you think that there's like specific like industries that AI shouldn't really be implemented in, or is like relatively difficult to implement in?
Yeah, I think applying AI to the business, right, is quite a different topic, right? And fundamentally, it's no difference to apply any technology, right? And when you apply AI or not AI, right, any technology to your business problem, and you truly understand what is the problem, will this technology help, right? That's fundamental process, right? And it's not about how good is technology, right? I think you really need to figure out what is the problem, right? And then you can find out what is the right solution, right? And it could be the AI, could be general AI, could be just simple heuristic rules, right? Could be just improve the existing process using some very traditional tools, right? I think this is irrelevant, right? Is AI or not AI? I don't think it's irrelevant. It's relevant, right? It's mostly you identify the problem, right? And then you're trying to figure out if this is the right solution. Of course, right? In order to identify the solution, right, you need to have a broad understanding, right? What is AI, for example, right? What is generative AI? And then give you some high level ideas, right? And when you solve the problem, right, and you may have some insight of the technology. And again, if you're not an expert in this place, there's a lot of the expertise, right, in AI and general. Right? You can always, as a business owner, yeah, you can always consult, right, and with the technology expertise to understand if this is the right problem to solve. I think one problem I've been working AI for really long time, and I think one challenge is right for certain people right working the AI, they say, oh, AI can solve everything. It's not the case, right? Even as powerful as today Gen AI, still right we have a lot of problems cannot solve by Gen AI. So I think we probably should have started if this is the right problem to solve, right, or not, right? I think that you always need to thinking hard, right, if this is the right problem to solve. And before we even get into which technology we pick to identify the business problem. And I think the first thing, yeah.
Yeah. Okay. Thanks for that. And then one more question that we had is basically, I guess, how do you envision like generative AI being used like outside of businesses? Like, I've seen that there's been a lot of talks for like generative AI and also just AI in general being involved in like education or also just like general like training for, and like fitness areas.
Yeah.
And what specifically do you like think about that?
Yeah, I think for example, right, and very simple, right, and if you're familiar with any of these tools, right, and ChatGPT or the Meta AI models or the Anthropic models, right, there are a lot of good generative models there. For example, it's just learning, right, and you could already right working with all these AI models. Let's say if a new topic, right, you never touched before, right? Let's say in this case, diffusion models, right? If you have new topics, you can pretty much talk to all the AI models. You can tell them, oh, can you give me the idea what this model is, how this model works, right? You can be essentially already working with all the AI models as your tutor or as your professors. They are really good, actually. It's already very powerful, right? There's an old concept called expert system, right? Which it was, I think, a terminology coined by 80s, right? So essentially, there's some expert system can answer any questions you have. Yeah, essentially, all the generative models today is the vision we already have, like 30 years ago, but even much more powerful. right? And if you use ChatGPT, Meta AI, or Gemini, Google Gemini, they are already very knowledgeable. You can think about it, right? They learn pretty much all the text generated by humankind, generated by human, and in the past 10,000 years, right? So they already have the knowledge of all human accumulated. So they are already very powerful. So essentially, any question, anything you learn from your class, right? They already have the knowledge. So all you need is just ask him the right question. We call it prompt, right? And prompt engineering, right? So as long as you ask the right question, you'll get the right answer. So it's essentially already there. So it's already a very powerful, I would say, education assistant, right, for anyone, right, in this world.
Yeah. And then I guess just an add-on question, like, for example, if you give a specific prompt, they'll give an answer, but there's also a lot of like concerns I've seen with like whether the information will be true or not, or whether like the information that's like fed to specific like AI models are like they don't have bias or they don't have like anything that like discriminates against people. And how specifically do you think like that could be improved or like made sure of for like AI?
Correct. It's called AI safety, right? So essentially, and during the model training process, right, didn't cover all the generative AI model training process. In the model training process, right, and essentially there are two steps. And the first step we call the pre-training, right? So basically no human involved, right? And basically all the transformer was trained first, right? And it just feeding all the text, for example, and from internet, right? And the model get trained over like a month, for example, right? I think GPT 3.5, right, was trained over 6 months, right? And 10,000 GPUs. That's the first step, right? So the model just learns automatically, right, without any human beings involved. So we call this base model, right? And first trained using any of the text, right? The general base model. And then the second step, right, and we call the supervised fine tuning and or human aligned process. So essentially, right, in these steps, right, we have human involved, right, and basically evaluate the output from the model and provide feedbacks. So you essentially tell the model, oh, this is good, oh, this is not good. So that's the basic process. And then we force the model to learn, right? And according to the human performance, right? We also call performance learning, right? So basically human will provide some feedbacks for the model output, right? So that's basically the second process. Of course, right? Then there's the last steps, right? And once we did all this model fine tuning, performance learning, and in real time, right, we also add another layer mostly, right? And we call the content moderation layer, right? If you have some very harmful content, right, and a harmful sentence, for example, input or output, and we call the content moderation model will catch, right, and all this bad content. So there are many steps and technology involved, right, and to make sure, right, and the model can generate, right, and the good and the content. But again, this is not 100%, right? No matter how careful we do, right, and train the models, right, and add a content moderation component, sometimes it still generate harmful content. But again, think about it, like just like a real human beings, right? We generate a lot of harmful content too, right? Every day, we create a lot of hallucination as well, right? Of course, right? We want to hold the high bars of the AI's machine learning, but think about a human being itself, right? And hallucination is one of the nature of the human beings. We do a lot of hallucination ourselves, right? And not every single sentence we speak is 100% authentic. Or so I think inherently, right? And the model was trained by all the human generated text on the internet. So I think a lot of problem actually is inherited from a human being. It's not because the AI technology itself. It's really the human being ourselves. We generate a lot of harmful content. We have a lot of hallucination ourselves too. So that's a model learned from all these informations, right? That's why the model also generates some of the harmful content. And that's why I think another process we do is during the pre-training process, right? We do a lot of data cleaning, right? And we filter a lot of harmful contents before we train the model to make the model more clean. Yeah.
Hi, thank you so much for coming again. I think Eric's having some technical issues, so we'll have to end Q&A here.
Great. Okay. Yeah. Nice to meet you guys. Right. And
Thank you.
hopefully,
Yeah.
right, and you learned a few things. And really nice to talk to you guys.
Yes, your talk was very interesting. Thank you so much.
Thank you. Bye.
Bye. For the rest of our contestants, we're going to begin the closing ceremony and raffle in a moment at 5 p.m. So see you all then. Welcome back, everyone. Thank you all for competing in our contest today. Now that you've had a quick break from programming, we can move on to the winners and raffle for today's contest. We'll only be covering pre-college teams in the following slides. After the top 5 pre-college teams in each division, we'll then have another 2 slides honoring all top teams, including college teams, beginning with the novice division. In 5th place, Bill Nye the Science Guy. Congratulations on winning 5th in the novice division. In 4th place, Ban, or BAN. Congratulations. In 3rd place, Girl Power. Congratulations on winning 3rd in novice. In 2nd place, congratulations on winning 2nd. And our novice division champion. Congratulations on winning the novice division. Now onto the advanced division. In 5th place, Placeholder. Congratulations on winning 5th. In 4th place, Panini Penguins. In 3rd place, Eric is not beating the allegations. Congratulations on winning 3rd. In 2nd place, Redacted Team Name. Congratulations on winning 2nd. And congratulations to Elastic Enormous Eggs for winning our advanced division. Here's the full list of novice winners. And here's the full list of advanced winners. You will shortly be able to see the full leaderboard on the contest website after we unfreeze the leaderboard. The standings will be up for a few days after today. The problems will also soon be added to a Code Forces gym where you can upsolve them. Congratulations to everyone who placed, and a huge thanks to everyone who participated. We'll post the winners of today's contest to our website shortly. Don't be discouraged if you didn't win anything. You still have a chance to win something in the raffle, which we'll move on to right now.
There's a lot of great prizes to be won here, so good luck to everyone. Let's pull up the spinner and see who wins. Firstly, we have the Discord Nitro subscription, which there will be 5 of, and the first winner is Wang Chi Ho from Elastic Enormous Eggs. The second winner is Hyun Hai Dong from the YouTube link. Our third winner is Mark Zhou from Cow Fan Club. Our fourth winner is Kush Sharma from Code Forces LGM. And our last winner of the Discord Nitro is Dila Fruz Chirabove from Tech Titans. I'm sorry if I butchered that. All right, next we'll be moving on to the $25 AOPS coupons, and there will be 4 of them. Our first winner is Duru Ozer from TR LOL 24 team. The second winner is Tanush Chauhan from Random Team. The third winner is Ethan Luo from Yi Song Carey. And our last winner is Keshav Venkatesh from that team. All right. Next, we have the Red Dragon gaming keyboard and mouse. And the winner is Kaushik G. Ear from the Blasters. Oh, wait. There's only one of those. And then lastly, we have the second gen AirPods, and the winner is Eric Husu from Eric is Not Beating the Allegations. And those are all our raffle prizes. Congratulations to everyone who won a raffle prize as well. All right, so if you want a placement prize today, have one team member send us an email at contact@teamscode.org. The email must include the following information: team name, rank and division, full name, and email address. If you want a raffle prize today, the email must include the following information: team name, division, full name, email address, and mailing address. Furthermore, if you sign up for XCamp using the coupon code, also email us with team name, division, full name, and email address. If we do not receive an email from you within 7 days, August 4th, we will not be sending prizes to you.
So yeah, that's all the information we kept.
We'd like to give a big thanks to XCamp, vPlanet Coding, and Luminar Central for making these awesome prizes available to you. Without them, our contest would not have been possible. Thanks again to everyone who took the time out of the day to come to compete. We hope everyone had a great time today, and we look forward to seeing you again for our future contests. Before you go, we greatly appreciate it if you could subscribe to our YouTube channel, follow our social media accounts, and fill out our feedback form. Additionally, our TeamsCode officer applications are open, so feel free to apply. Have a great rest of your day, and we hope to see you at our next contest.